Okay, in the last video we talked about transformations and also about one of them being dilations, and I know that you had worked on dilations with Desmos in class. So we can take dilations and we can use them to dilate figures bigger or smaller on graphs, and we just do that by adjusting the vertices. So here we have a problem that says a figure has the vertices x at -3 and 6, y at 3 and 0, z at 3 and 3, and we want to find the new vertices after a dilation with a scale factor of 3. So if we call k our scale factor, which in this case is 3, but for now I'll just use it as a generic k, and I have a point x, y, then my new point is determined by taking each coordinate and multiplying it by the scale factor. So in this case I would have x, k times my x, and k times my y. Okay, now if k is 3 and I have some xy, then I do 3 times x and 3 times the y. So let's apply it to this figure here. So we have the point x, which is -3 and 6, and the point y, which is 3 and 0, and the point z, which is 3 and 3. So I'm going to multiply it by my scale factor, k equals 3. So that means, am I going to call my new point x prime? So I have, multiplying both these by 3, I get a new point of -9 and 18. Then I multiply both these by 3, and I have my new point y prime. 3 times 3 is 9. 3 times 0 is still 0. Then I have my new point. Multiply each of these by 3. My new point is the z prime, and this is going to be 9 and 9. Okay, simple enough. Let's see what that would look like on a graph. So I'll go to Desmos, and I've plotted the original points, x, z, and y, and I need to enter in my new points. Okay, so my new point, my new x prime, we said was going to be -9, comma 18. And I want to label that as x prime. Okay, and does it show up? I need to probably blow out a little bit. Yep, it shows up there, which is what we would expect. And then I need my new y prime point, which was going to, we said was 9, 0. And we'll label that y prime. Okay. And that shows up there on the line, which it should, here in black. And then I have my new point z prime, which would be 9 and 9. And let's see, z prime. Okay. And sure enough, that's out there. So we have moved the triangle, and that would be a triangle, x, y, z, to the location x prime, y prime, z prime. Okay? And I can't really draw the lines on this, but you should be able to figure that out. That I've just had blown up the triangle, basically. Okay, let's look at another one. Oh, let's do another dilation here. So now I have a figure has vertices D at -4 and 4, E at 4 and 8, F at 8 and 8, and G at 4 and 0. I'm going to graph the figure and the image after a dilation with a scale factor of 1/4. Okay, so I have my new points, -4 and 4. And E, so this is a 4-sided polygon, 4, 8, and F is 8, 8, and G is 4, 0, and my scale factor K in this case is going to be 0.25 or 1/4. So I'm going to multiply everything times 1/4. Let me just do it as a fraction, be easier. Take up less room. Times 1/4. Okay, and each one is one. We multiply by the same scale factor. Okay. And you don't have to write all the time what you're multiplying by, but I'm just doing it for clarity. So my new point D prime is going to be -4 times 1/4 or -1, and 1, 4 times the 1/4. My new point E prime is going to be 4 times 1/4 or 1, 8 times 1/4 or 2. My new point F prime is going to be 8 times 1/4 is 2, and 8 times 1/4 is 2 again. And my new point G prime, which is 4 times 1/4, which is 1, and 0 times 1/4, which is 0. So I have to plot that new point. Okay. And let's go to it here. I have already plotted the original. Now this point by itself out here is my origin. All right. This graph doesn't have the axes on it, but this point down by itself is my origin. And I want to go ahead and plot my new points. So we said D prime was going to be -1 and 1. So that would be -1 and 1 would be here. And my E prime is 1 and 2. So 1 and 2 would be up here. And my F prime is 2, 2. 2 and 2. Is there, and my G prime is 1 and 0. So 1 and 0 would be there. Okay, and let's see if I can figure out. I'm going to go ahead and see what I can do here as far as a dilation. I have a dilation scale factor of 0.25, which is 1/4. I want to select the original polygon, and I want to apply my dilation, and sure enough, it goes right to the points that I plotted. Okay, so that's dilations, both expanding, contracting, and that should set us up for some problems in class. So I'll see you then.